This is Bob Capetta from the College of the Florida Keys, and this lesson is an introduction to factoring. So we're first going to look at 7x squared minus 14, and we want to write that as a multiplication problem, as something times something else. And we do that by looking at each term and asking what is the greatest common factor, what is the largest number or algebraic quantity that can go into both 7x squared and 14. And the answer to that is 7. The greatest common factor here is 7. So we will extract 7 from each, factor it out. So 7 times what is what we're looking for. So if I divide 7x squared by 7, I just get x squared. If I divide 14 by 7, I just get 2. So the result would be that 7x squared minus 14 is 7 times x squared minus 2, and you check that by distributing. 7 times x squared is 7x squared, 7 times 2 is 14. Indeed, that's correct. We factored out the common factor, factored out the greatest common factor of 7 to get our result at 7 times x squared minus 2. And whenever you're doing factoring, always look to see if there is a common factor to extract first. Next, I'm going to look at negative 2x squared plus 26x minus 22. Now you have a choice here. There is something common to all three terms, to negative 2x squared, to 6x, and to negative 22. You could use 2, but frankly, I'm going to choose negative 2 instead. More often than not, if the leading term is negative, it's more helpful to factor out the negative number. But it certainly wouldn't be wrong if you factored out a 2. So I'm going to factor out a negative 2 here. I'm going to say the common factor. Can't call it the greatest common factor because 2 is greater than negative 2. But the factor of choice I'm going to use here is negative 2. If I factor out negative 2, what am I left with? Negative 2x squared divided by negative 2 would be x squared. 6x divided by negative 2 would be negative 3x. Negative 22 divided by negative 2 would be 11. So notice how I've done this. I've written the negative 2 out in front and then divided each piece by negative 2, multiplying by negative 2 and dividing by negative 2. What will our result be? I'm rewriting the minus 22 as plus negative. So negative 2x squared over negative 2 again, x squared, 6 over negative 2, negative 3x plus 11, as we mentioned. So by extracting a negative 2, that's the result that we get, and that will be helpful for us in solving many types of problems. All right, next I want to factor 10x cubed plus 20x squared plus 15x. So what is common to all three terms? 10, 20, and 15. Well, if 5 is common to all three terms, but that's not enough. We also have x cubed, x squared, and x. So 5 is common and x is common. So I want to extract a 5x from all three terms. So I need to take 10x cubed divided by 5x, 20x squared divided by 5x, 15x divided by 5x. So 5x times all those division problems I just told you, multiplying by 5x, dividing by 5x. 10x cubed divided by 5x is 2x squared. 20x squared divided by 5x is 4x. 15x divided by 5x is 3. And you can certainly check your answer distributing 5x times 2x squared, 10x cubed, check. 5x times 4x, 20x squared, check. 5x times 3 is 15x, check. Always a good idea to check your answers as you're doing factoring. Next up, I have 6x to the 4th, y to the 7th, plus 4x squared, y to the 4th, plus 8x cubed, y to the 9th. Let's look at the numbers first. 6, 4, and 8 have a common factor of 2. X to the 4th, x squared, x to the 3rd, looking at the x's, all of them contain at least an x squared. So that will be part of the common factor. Y to the 7th, y to the 4th, y to the 9th, they all contain at least a y to the 4th. So y to the 4th will be part of the common factor. So we had 2, we had x squared, and we had y to the 4th. So we're going to divide each term by 2x squared y to the 4th and see what remains. So 2x to the 4th times this divided by 2x to the 4th, this divided by 2x to the 4th, this divided by 2x to the 4th. 6 divided by 2 is 3. X to the 4th divided by x squared is x squared. Y to the 7th divided by y to the 4th is y to the 3rd. 4 over 2 is 2. X squared over x squared is gone. 1 over 1. Y to the 4th over y to the 4th, 1 over 1. So all I'm left with here is 2. And then here 8 over 2 is 4. X cubed over x squared is x. Y to the 9th over y to the 4th is y to the 5th. So there we go. 2x squared y to the 4th, 3x squared y cubed plus 2 plus 4xy to the 5th. Factoring out our greatest common factor of 2x squared y to the 4th. Next, I want to factor 2ax plus 3ay plus 10bx plus 15by. So I'm going to factor two pieces at a time. 2ax plus 3ay, then I will factor 10bx plus 14by. How is that going to work? 2ax plus 3ay, the common factor is a. Extracting an a, I'm left with 2x plus 3y. Distribute a2x, a3y, indeed, that checks. Now I'm going to look at 10bx plus 15by. What's common to both of those? A 5 and a b. When I extract 5b, 10bx divided by 5b is 2x. 15by divided by 5b is 3y. So I have 10bx plus 15by is 5b times 2x plus 3y. Now we're adding these two together. A times this parentheses plus 5b times this parentheses. And the reason that this can work, the reason that this will factor, is that both pieces have 2x plus 3y in them. If those parentheses are different, your strategy is not going to be successful. But you'll notice here I can divide both of these by 2x plus 3y. Because notice that's a times 2x plus 3y, 2x plus 3y times a when we distribute that way. And then I have 2x plus 3y times 5b here, which is that thing. So extracting the 2x plus 3y, dividing each piece by 2x plus 3y, my result is going to be a plus 5b. Next, I have ax plus 3a minus 2bx minus 6b. I really don't like those minus signs. So I'm going to change the minus signs to plus negative. Ax plus 3a plus negative 2bx plus negative 6b. And we're going to look at two pieces at a time. First, looking at ax plus 3a. If I factor out the a, I'm left with x plus 3. Second pair, I have negative 2bx plus negative 6b. I can factor a b out of each of these. I can also factor a negative 2 out of each of those. So I'm going to extract negative 2b. If I divide this first piece by negative 2b, I just get x. That's good. If I divide this by negative 2b, the b's go away. Negative 6 over negative 2 is positive 3. So indeed, that's good as well. So that when I add these two together, a times x plus 3 plus negative 2b times x plus 3. Each of these pieces has that x plus 3 parentheses. If that is the case, I can extract that. I can factor that from these two statements. Extracting x plus 3, dividing this first piece by x plus 3, I get a, plus dividing this piece by x plus 3, I get negative 2b. So dividing that out, we get x plus a times a plus negative 2b. Notice x plus 3 times a, check. X plus 3 times negative 2b, check. Now, plus and negative is a little informal way of writing it. A more formal way would be to rewrite that as a minus 2b. So our preferred answer would be x plus 3 times a minus 2b. Let's take a look at another one in that realm. 2x cubed plus 3x squared plus 10x plus 15. Doing two at a time. 2x cubed plus 3x squared, I can take an x squared out of each of those. 10x plus 15, I can take a 5 out of each of those. So extracting the x squared, 2x cubed divided by x squared is 2x. 3x squared divided by x squared is 3. 2x cubed plus 3x squared, or x squared times quantity, 2x plus 3. Now we have 10x plus 15. What's common to both of those is 5. Extracting the 5, 10x divided by 5 is 2x, 15 divided by 5 is 3. 5 times 2x is 10x, 5 times 3 is 15. Again, we're very happy that both of these components have 2x plus 3. So if I add everything together, I have x squared times 2x plus 3 plus 5 times 2x plus 3. 2x plus 3 can factor out. And when I factor out the 2x plus 3, what's left? X squared plus 5. So that's called factoring by grouping. When I have those 4 pieces, that's a nice strategy that enables us to solve some problems. But again, the key idea is the only way this is going to work if both of those parentheses have the same numbers in them, the same exact concept. That's what enables you to factor that out. All right, this time I want to factor 5y cubed plus 2y squared minus 10y minus 4, which I will rewrite as 5y cubed plus 2y squared plus negative 10y plus negative 4. The minuses can cause some trouble here, so I think if I make it plus negative, it's just a little safer. So again, I have this pair of things to work with and this pair of things to work with. 5y cubed plus 2y squared, negative 10y plus negative 4. 5y cubed plus 2y squared, the y squared factors out. 5y cubed divided by y squared is just 5y. 2y squared divided by y squared is just 2. Now, negative 10y plus negative 4, what is common to both? Well, 2 is common to both, or negative 2 is common to both. So my strategy is going to be to divide out negative 2. Negative 10y divided by negative 2 is 5y. Negative 4 divided by negative 2 is positive 2, and that makes us very happy that we have the same numbers in the parentheses when I divide out the negative 2. Now, putting these two terms and these two terms together, it winds up with this piece adding this piece. Y squared 5y plus 2 plus negative 2 times 5y plus 2. Each has a 5y plus 2. Thank goodness, that's what enables this process to work. We divide out the 5y plus 2, and we're left with y squared plus negative 2. But of course, y squared plus negative 2 is a rather informal way of writing it. More formally, we would call that y squared minus 2. All right. Next, I have x squared plus 7x plus 12. Now, this has 3 terms. When we've done factoring by grouping, we've looked at things that have 4 terms. But I can make this have 4 terms by breaking up 7x. 7x is something plus something, so let me try it and see what I get. I said, let's let 7x be 5x plus 2x. Can I successfully factor this by grouping? If I put x squared plus 5x together, that's x times x plus 5. But 2x plus 12, factoring out the 2, I get 2 times x plus 6. This is not acceptable. The 2 things in the parentheses are different, so that strategy was incorrect. But is there another way I could have done it rather than 5x plus 2x? Let's try 4x plus 3x. So if that's the case, we'll factor an x out of these 2. X times x plus 4. Factor a 3 out of these 2. 3 times x plus 4. And there you go. Both of the things in parentheses are the same, which enables me to factor that out. Factor out the x plus 4, and the remaining values are x plus 3. So I have successfully factored x squared plus 7x plus 12 into x plus 4 times x plus 3. If you're not certain, distribute. X squared plus 3x plus 4x, which is 7x plus 12. Looks good. Got another one. 6x squared plus 23x plus 20. This is a challenging problem. It's 3 pieces. I'm going to have to make it 4 by breaking up 23x into something and seeing if it works. The first thing I tried was 3x plus 20x. Well, if that's the case, I can factor 3x out of these 2 guys, and I can factor 20 out of those 2 guys. What does that leave me? 6x squared divided by 3x, 2x. 3x divided by 3x is 1. So 3x times 2x plus 1 plus factor out the 20. 20 times x plus 1. The things in the parentheses are different. If that happens, the strategy is incorrect. So I'll try it again by breaking up 23x into some other pair of numbers. This time I went with 8x plus 15x. Let's see if this works. 6x squared plus 8x, each of them have a 2x common to each other. 15x plus 20 each have a 5 common to each other. 6x squared divided by 2x is 3x. 8x divided by 2x is 4. 15x divided by 5 is 3x. 20 divided by 5 is 4. And we are very happy because the two parentheses are the same. So we can factor out the 3x plus 4, and what's left? 2x plus 5. And that will conclude this lesson.